quartile system. Basically, we break the data up, breaks the data up to 4 parts. Okay, so what we had before, let's say we have the data already sorted, and then the median will separate the data into lower half and upper half. This is the lower half, and this is the upper half. This is the median. Then the first quartile is the median of the lower half. That's the first quartile, and the median of the upper half will be our third quartile. Okay, the median is also known as the second quartile. Now, the way it is being done will be that the first quartile and the third quartile will be the median of lower or upper half without the median of whole data. Maybe to be more precise, without Q2. Without Q2, without Q2. So for example, suppose we have this data set. I put them in order right away. Let's say I have 7, 10, 15, 17, 20, 21, 28. Then of these 7 data, the median will be 7 data. So 7 plus 1 divided by 2. That's data number 4. The fourth data is the median. Okay, so the median is 17. Now then, the lower half will be all the numbers before that median, and upper half will be all the numbers after that median. Okay, then the first quartile will be the median of the lower half, which is there are 3 data, right? Okay, 3 data plus 1 is 4 divided by 2, so the second data. In other words, we apply that principle again, that to know the position, the number of data in that set at 1 divided by 2. Okay, there are 3 data in that lower half plus 1 divided by 2. We get the second data. Okay, now the third quartile will then be the second data from the top. In this case, will be 0.1. Okay. Now let's do one more example 2. This time you do it. Let's say the data set are maybe 13, 16, 17, 17, 18, 18, 18, 19, 20, 21, 22, 22. So they are how many data here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 data. So n equals to 12. plus 1 divided by 2, that's data number 6.5. So between data number 6 and data number 7. This is to find the position. Okay. Data number 6 is 1, 2, 3, 4, 5, 6. So data number 6 is 18. Data number 7 also 18. This is the 6. This is the 7. And the median is right in between. So the median is, remember, if the median is between two numbers, you need to write it as the average of two numbers. Right? So 18 plus 18 divided by 2, that's equal to 18. That's the median. Now then, the lower half will be everything before the median. But the median is between 6 and 7. So data number 6, it's still in the lower half. And data number 7 will be in the upper half. Okay, this is lower half. This is the upper half. So the first quartile will be, now there are 6 data in lower half. Okay, 6 data plus 1 divided by 2. That's 3.5. So between data number 3, the third, and the fourth. Data number 3 is 17. Data number 4 also 17. So the first quartile is 17, while the third quartile is data number 3.5 from the top. Data number 3.5 from the top. So this is the third from the top, and this is the fourth from the top. Okay, so there will be 20 plus 21 over 2. That will be 20.5. If you have finished reading chapter 2, there's something called box and whisker or box plot. Looks like this. Looks something like this. Looks like this. Now, this box plot diagram summarizes those 5 numbers. What are those 5 numbers? The one here is the first quartile. This is the median. This is the third quartile. This is the minimum. And this is the maximum. Okay, so in this case, the minimum will be 13. And then the first quartile is 17. The median is 18. The third quartile is 20.5. And the maximum is 22. Now, these 5 numbers tells us the cutoff, like around 25%, around 1/4 of the data in this interval, another 1/4 in this interval, another 1/4 in this interval, another 1/4 in this interval. Approximately. That's what quartile system is doing. It creates the sorted data into 4 equal parts. Now remember, the data has to be sorted first. Okay, if it's not sorted, then you put them in order. Now, this kind of question, I think, it's not too hard yet, but you need to be able to visualize that. Why? Because then the harder question will be, what if we have, what if we have group data single point? Let's say we have this data here. X, let's say this is 13, 14, 15, 16, 17, and the frequency are let's say 5, 7, 8, and then 11, 9. Now we did from last Wednesday, we compute the mean and the variance and standard deviation, right? And I do expect you to know how to do that very well already. Okay, now the question here is how do we find the first and the third quartile? Find the median, which I assume you already know, the first and the third quartile. Now we get the total first, we get a total of 40, right? Okay, so for the median, where's the position? 40 data plus 1 divided by 2, that will give us the 20.5th position. So it's between data number 20th and now data number 21st. Now, what is data number 20th? Look at the cumulative. The first class has 5. Up to the second class, 5 plus 7, that's 12. Up to the third class, 12 plus 8, they are 20. Okay, so data number 20 is still 15. Data number 21st is 16. Therefore, the median is 15 plus 16 over 2. That's 15. Now, because the median is data number 20.5, between the 20th and the 21st, right? It means there are 20 data in the lower half. And also in the upper half. Okay, now then, what is the first quartile? The first quartile will be the median of the lower half. 20 plus 1 over 2. That gives us the 10.5. What is data number 10 and data number 11? Now from the diagram, from the table, you see that the first 5 data is 13. The next 7 is 14. So data number 10 and data number 11 are both 14. You can imagine it this way. You can imagine it this way. You can imagine if you write them all out, 13 5 times, right? And then 14 7 times. So you see from the lowest one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is data number 10. This is data number 11, right? Okay, so the first quartile will be the middle in between 14 and 8. Okay, now likewise, if we do it from above, the 10th data, if we do it from above, the 10th data will be, now the top 9 are 17, right? So we have 17, 17, 17, 17, 9 times. The 10th one from the top is 16. The 11th from the top also 16. So Q3 will be 16 plus 16 over 2, that's 16. That's for the quartile system. Now, of course, you don't need to show these. Though. You don't need to. Whatever I write here, whatever I write here, no need to show. Okay. Do on scratch. You don't need to show it. Okay. Or if you do it aside on the side work of your paper. Okay. Don't get it mixed up with the work. Now the thing is, the method that I show you down here is not reliable because if you need to write down everything, imagine if I have 400 data, then you will have very hard time. Okay, so try to imagine if you put those numbers in order instead. Okay, but don't without writing it down. That's what I mean. Let me give you some sample for you to practice. Example 4. Let's say we have this data set. Start from 17, 18, 19, 20, 21, 22. Let's say I have 24 here and 27 here, and then I have 32 here. I have 10 here, 5, and then 4. Find the median, the first quartile, and then the third quartile. I think the total is 102, isn't it? Yeah, 102. Okay, let me give you 3 or 4 minutes for 24. We want to find the median. Let's see where's the position first. The median. There are 102 people, or the data, 102 data plus 1 divided by 2. That will give us 51.5. So I need to look for data number 51st and data number 52nd. Cumulatively speaking, the first class is 24, up to the second class, that's 51. Oh, so data number 51st is 18, and data number 52nd will be 19. Yeah, because the total up to the first 51 data, the last number, the 51st data is 18, right? And that's already exhausted, like here. Now then data number 52 will be 19. Yeah, you can imagine this way. 17, you write it 24 times. And then 18, you write it 27 times. Okay, so the last 18 is data number 51st. Okay, and then the next 32 are 19s. There are 32 of them. Okay, so 51st is 18, 52nd is 19. So the median will be 18 plus 19 over 2, that's 18.5. Now from here, we also see that the median is between data number 51st and data number 52nd. So there are 51 data points, 51 data in the lower half. Okay. If you imagine this is our median, then this data set here is the lower half. Okay, now then we apply the median formula again. 51 plus 1 over 2, that gives us the position for the median of this lower half. I think this will be 26. Data number 26. Now the first 24 is 17. So the next two, so 24 up to here, right? Okay, 24, 25, 26. So the first quartile will be the 26 data, which is 18. Now the third quartile will be the 26 data from the top. So the top 4 is 22. The next 5 from the top is 21. The next 10 from the top is 20. Okay, so data number 26 must be 19. Okay, now that's for our quartile system discussion. Now some notes. We have seen methods to find median, which we learned last time, first quartile and the third quartile, given raw data and group data single point. For group data interval, the method to find median is beyond the scope of this course. Actually, I believe you can find it. I believe there is such formula in our textbook. They use formula in our textbook. Usually it's in textbook, but it's like in the exercise set. Okay, now, but because it is done by approximation, consequently, Q1 and Q3 for such case like group data interval are also not discussed. Okay, that's for this quartile system. Let me check one thing from the past. 17 last week. So I did teach you how to use calculator to find the standard deviation. Okay, yeah, I did teach you how to use calculator. But in my class, especially my test one, or my quizzes and test one, I need you to compute the variance and standard deviation the way I show you in class, not using calculator. Okay, not using calculator. You need to use do it my way. You can use calculator just to confirm if you got the answer correct. Let's go on with the second part of this today's discussion is on constructing frequency distribution. So suppose we are given a raw data set, but it's a big raw data. Then how do we construct frequency distribution? Let's first look at some terminologies. Suppose I have this frequency distribution here. Frequency distribution interval. So let's say this is my outcome and this is the frequency. Let's say this is from 12 to 18, 19 to 25, 26 to 32, 33 to 40. Frequency, I just make up numbers, 17, 18, 25, 10. Now, these numbers here, all these numbers here are called lower class limit. Lower class limit. Our textbook doesn't talk about this though. Okay, now lower class limit is if you have an interval for that class, then the smallest number registered in the interval is the lower class limit. Okay, lower class limit is the smallest number registered. Now, the upper class limit will be the largest number registered, the largest number you see for that class. And it is called upper class limit. So the upper class limit for the first class is 18, 25, 32, 40. Okay, now we have more. So if our textbook doesn't even mention about lower and upper class limits, then for sure they don't mention about boundaries. We have lower class boundaries, lower class boundary. We have upper class boundary. Now, how do we get those lower class boundaries and upper class boundaries? Let's take a look on the number line and imagine if I put these intervals accordingly. So 12 to 18, that's the first class, and then 19 to 25 in the second class, 26 to 32 in the third class, 33 to 40 in the last class. Now, the yellow one are lower class limits. The blue one are upper class limits. Now, lower class, class boundaries are the number that is actually separate those limits. Now, so imagine if you live with your neighbors, right? Okay, and let's say this is basically your houses, okay? But most of the time, your house and your neighbor's house not adjacent, not stick together. There's some gap in between, right? Now, then in statistic, what is the fence? Now, this is the fence, okay? Which is always the midpoint of upper class limit of the previous class and lower class limit of the next class. It's always the midpoint of those two. It's kind of hard to explain it in words, I know, okay, especially if I need to be technical, but I hope this picture gives you the good idea, okay? The boundaries has to be in between, okay? So between the first class here and the second class here, okay, the upper class boundary for the first class is the midpoint of this 18 and 19. Okay, now that upper class boundary for the class of 12 to 18 is also lower class boundary for the next class. Okay, so you see between this 19 and 18 here, in between, the midpoint between them will be the boundaries. Okay, will be the boundaries. Now you do likewise for the other classes. So for example, the one here, upper class boundary for the second class, it's between 25 and 26, that's 25.5, which they share, being shared with the next class, 25.5. This is 32.5 between 32 and 33, right? This is also 32.5. So you see these two numbers must be the same. Now, the purpose of boundaries basically tell us the cutoff of the where we put certain data into which class. So, for example, let's say these numbers here represent the ages of people coming to Thomas classes. Okay, let's say these are the ages of people coming to Thomas classes. Now, if somebody's, let's say 30 years old, it's easy, it must be in this class. 37 years old, it's easy, it must be in this class, right? Now, the thing is, what happens if that person is 25 years old plus, for example, 3 months? How about plus 7 months? How about plus 10 months? If we need to do rounding, how far we do rounding? And doing the cutoff, therefore the boundaries give us a good guide. Oh, if you are 25 years old plus 3 months, that's still less than 25.5, then you fall into this class. Even though you are over 25 years old already, but still not qualified into the next class. Okay. However, if you are 25 years old plus 10 months, then you are actually closer to 26. You are closer to this class compared to this class. Okay. That's the logic behind the need of using boundaries. Now, another purpose of boundaries is to tell us how far the lowest class can go lower and how far the upper class, the highest class can go higher. In other words, what is the lower class boundary for this class of 12 to 18? Okay, how far you go lower from that 12? And the answer is following how far you extend to the right, that's how far you extend to the left also. So this one here, this is 18.5, right? Okay, in other words, from 18 to 18.5, you extend 0.5. So you extend 0.5 to the left also, that's 11.5. Okay. Now, for the highest class, this is 32.5. Now you extend 0.5 unit from 32.5 to 33, right? 32.5 to 33, you extend half units. So here you extend half unit also. So this will be 40.5. Okay, that's how the boundary is being done. Now the last part, which is not related to our discussion of constructing frequency distribution, but just a little extra stuff, is called relative frequency. We will use this when we get to probability, relative frequency. That's the frequency for the class divided by the total frequency. So the frequency of the class divided by the total. Relative frequency is usually expressed either in percentage or in decimal. However, in my class, I'm okay if you just leave them in fraction. So this one here is 18 over 70, 25 over 70, 10 over 70. But what you should not forget is you need to add them and the total should be 1. Okay, just like the total frequency, you need to give the total there. You also need to get the total of relative frequency, which is supposed to be 1. Okay, now you always have this question in my test 1, and as I remember, that's always question number 7. Okay, once you construct a frequency distribution in number 6, right? Frequency distribution number 6. Then in number 7, you will need to copy that frequency distribution, and then you do this kind of extension to find lower class limit, upper class limit, lower class boundary, upper class boundary, and relative frequency. Okay, now I think this is not too hard to remember, and if you take a look in my old tests, even in my lecture, I believe, lesson 3 or lesson 4. Lesson 4, I mean lesson 4. If you look at my lesson 4, then you must have seen this also at that time. Okay, it's just terminology and understand, oh, what is this, what is that. Now, the thing is, I think I have never done a frequency distribution with decimals. Now, let me do it now. What happens if we have decimals instead? And how do we find the boundaries? And the same technique, actually, the same technique. Let's see example 2. Suppose we have this frequency distribution. Oops, you know what? Let me use that. Let's say we have this frequency distribution. This is our x. Let's say from 24.7 to 25.8, and then 25.9 to 27.0, 27.1 to 28.2, 28.3 to 29.4. The frequency. Now then, what will the lower class limit and upper class limit be? Those are easy. This is the lower class limit, while these are the upper class limits. Now, the thing is, how about lower class boundary and upper class boundary? Lower class boundary and upper class boundary. We see that the upper class boundary for the first class is the same to lower class boundary for the second class, and it is the average of these two numbers. So you imagine if I have my classes from 24.7 to 25.8, and my next class is 25.9, start from 25.9 to 27.0. Okay. So the boundary will be between these two numbers. Okay, and the midpoint of that will be 25.8 plus 25.9 divided by 2. That is 25.85. That's the cutoff. Okay, and the lower class boundary for the next class will be the same. You see what I mean? Okay, so it doesn't have to be integers that you treat the same way. No, it doesn't have to be. Okay. It can be decimal. One decimal place is the one I show you here. It may be two decimal places, three decimal places, but the way we do the boundaries will be exactly the same procedure. Okay, it is based on what they present to us here. Okay, get the midpoint of these two numbers. Now, unfortunately, our textbook does not have these though. When they did the frequency distribution, the way they did it is just no, it's not. It's not the right way. Okay, it's not the right way. At least that's not what he's supposed to write. Okay. Now, if I go on, then this will be 27.05, which is the same with this 27.05. This is 28.25, which is the same to this. This will be 24.65, and this will be 29.45. Okay, that's how we get the boundaries. Now let's construct frequency distribution. So once we get the terminologies, then how to construct a frequency distribution. Given a raw data set, how to construct frequency distribution correspond to it. Corresponds to that raw data. Okay, I tell you the steps first, and then we will practice later on. Okay, the first step is find the range, which is the maximum minus the minimum. You know what? Let me get a data set right away. Let's say I take 417 Math 227 test 1. I happen to have it at hand here. Let's say this is the data set. Okay, let's say that's the data set. Move it a little bit to the left. Okay, now then, what is the range in this example? Step 1, the range will be the maximum is 96, the minimum is 3. So the range is 93. The second step, class width. We need to find the class width. Class width denoted by W is equal to the round up of the range divided by number of classes. Now, the number of classes usually is given in my question. Now, however, this notation here, it's not bracket, it's not bracket. Very similar to bracket, but it's not. Bracket is like this. This is bracket, right? Now, ceiling notation has no this part. Okay, no that part. Now, if you see this notation without this part here, the bracket, but without the bottom part there, it means we round up to the next integer. Okay, we round up to the next integer. But it doesn't have to be the next integer. It can be the next decimal place, the next second decimal place, the next third decimal place. Okay, so suppose in this question here, we need to break it into, let's say, into 4 classes. So the class width will be the ceiling of 93 divided by 4. divided by 4 gives us 23.25. 23.25. Okay, then from there, you always round up either to the next integer, which is 24, or to the next decimal, one decimal place, which is 23.3. Okay, yeah, so you round up. Never round down, never truncate. Always round up. Okay, the actual meaning of this notation, the ceiling notation, the actual meaning is actually round up to the next integer. Round up to the next integer. But in this case, you can also round it up to the next decimal place. So you can use 23.3 if you want. Okay, but because the data set already given to us in integers, right? Because this is all in integers, then I guess here you will round it to the next integer. Okay, so the class width is 24. So what after we get the class width? Then the lower class limit of the first class is usually, not all the time, but most of the time, is usually the minimum data. So in our step 3 here, when we construct our frequency distribution, the minimum is 3, right? That will be the lower class limit of the first class. Now then, from there, we keep adding W to get the next lower class limit. The W, the class width is 24. So I add 24 to get the next lower class limit, which is 27. Add 24 again to get the next lower class limit, which is 51. I add class width again, the 24 that we computed in step 2, to get the next lower class limit. Now, how about the upper class limit? The upper class limit usually done this way. So you see this is 27, right? You subtract by 1. That's 26. Thomas, can I subtract by 0.5? Yeah, you can if you want to. So you get 26.5. That's fine. Okay, just be consistent. Okay, just be consistent. Now then, from that 26, you keep on adding the class width again. Okay, you add 24, you add 24, you add 24. Okay, so this will be 27 to 50. This is 51 to 74, and this will be 75 to 98. Now you see that my 98 doesn't have to be the maximum. No, it doesn't have to be. Doesn't have to be the maximum. No, doesn't have to be the maximum. Okay, but the rule is you keep on adding the class width from the upper class limit that you have here. You keep on adding class width, class width, class width. Okay, that's how we do it. Now then, the last step is to do the tally. Tally the raw data into the frequency column. Okay, so the frequency here will be, you know what, let me delete the red colors so that it's not annoying us. When you compare with the original data, the original raw data, from 3 to 26. So the lowest one is 3 up to 26. So this is the lowest. How many of them? I think there are 11. Okay, 11. Let me use this color instead. So this is the cutoff. So the frequency for 3 to 26 is 11. From 27 to 50, 27 to 50 step, that should be 10, 13, 16, 18. Okay, so they are 18. Then from 51 to 74, 61, 51 to 74, they are 24. And then from 75 to 98, basically for the rest, right, that's 17. Now, after you're done with this, then you add these numbers here. Okay, you add these numbers here, happen to be 70. Okay, and make sure it's the same to the number of data you have here. Do not just assume that I have 17 data here, so the sum must be 70. No, no. Just in case you miscompute something. So you add this separately from finding how many data here. Okay, that way then we can confirm if we compute or construct that correctly. Okay, I have question coming in. Let me see. Okay, how did I get 4 from step 2? Oh, it's usually given. Like, how do we know that there will be 4 classes, Thomas? Well, the question will tell you, construct a frequency distribution with, for example, 4 classes. Okay. There's actually a formula for that, but again, that formula is beyond the level for this course, the scope of this course. Okay, so I will just give it to you. Usually the number of classes is at least 3, at most 4, but of course in real life it may be going up to 20 classes. Okay, we don't want to have too many classes too, okay, such that we are lost in details, but we don't want to have just two view classes either, because then we will approximate by too much rounding error. Okay, so the number of classes will be given in the question. Okay, now let me ask you to try this. You try to do it on your own, okay, following the same procedure. Do you write this down yet? Let me ask you to write down the procedure, at least the procedure. At least the procedure. And then I will give you another example. Let me give you one more minute. Okay, I assume you already copied that down. Now, let me give you the same data set now. The same data set, but this time you construct, this is example 2, construct a frequency distribution with 5 classes from the following data set. So instead of 4 classes, we do 5 classes right now. Okay, I think it should take you 1, 2, 3, 4, 5, 6, maybe 7 minutes. Okay, so let's come back at 5:15. You know what? Let's do together with your break. Let's come back at 5:30. Let's come back at 5:30. So including your 10-15 minutes break from now. Okay, so 5:30 we come back. We are done with constructing frequency distribution from here. Okay, now after we're done with this one data set, constructing frequency distribution from here, then I will go to, I will give you a new data set, and then we will ask everything possible from that data set. Okay, but for now, this is basically the last piece, the last missing link we need from putting everything together. Okay, at least up to what we have right now. Okay, let me ask you to construct frequency distribution with 5 classes using this data set. We come back at 5:30. I will start working on this. Step 1, the range is from 96 minus 3, that's 93. And then class width is the ceiling of the quotient of 93 over 5. That will be, I believe that's 18.6. But we will round it up to 19. Then the frequency distribution will be as the following. This is the X frequency. Start from 3 plus class width 19 becomes 22, plus class width 19 becomes 41, plus class width 19 becomes 60, plus class width 19 becomes 79. 5 classes, that's how I know I stop at 79. Now then, how about the upper class limit for each classes? For each class, that will be 21 here, that will be 40 here, 59, 78, and then I need to add 19 to this, that will be 97. Now I will do the tally. The first class from 3 to 21. Here there are 9 of them. The next class from 22 to 40. 40 up to here. So there are 12 of them. The third class from 41 to 59. Up to here. So there are 13. Then from 60 to 78, there are 20, okay. Then from 79 to 97, there are 16. I will add, I get 70. And that's it. We are done with the constructing frequency distribution. Okay. Any questions so far? No question? Okay. If no question, then let me put everything together from what we learned in the first day of class until now.
I have a question.
Okay.
I just want to know, how did you get the 9 in the very first one?
There are 9 data set that is valued from 3 to 21. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's what the tally for.
Okay.
Okay, maybe I colored it. there are 9 here. And for the second class, there are 12 from 22 to 40. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 of them, and so on and so forth. Okay, now let me put things together. I will do problems from my old tests. Let me choose which test. Let me take a look. Maybe from, oh, that's from 417. I don't want to do 417. 416 maybe. Maybe 416. So I will get rid of this page here. This. You will see that from all my test one, past test one, you can do problems number 1 to number 8 already. In fact, after my further explanation, you will see we will be able to do from number 1 to number 9. This is from fall 2016. I will do question number 1 to question number 9. And then if we still have more time, then I will do another one test, another problem from test 1. Okay, this is fall 16 math 227 at ELAC test 1, number 1 to number 9. I wonder if they will accept it. No, they will not. So fall 16 math 227 at ELAC College test 1, and then underscore 1 to 9. Okay, so I will do question number 1 to question number 9 only. But you will see in all my test 1, question 1 to number 9 are all the same. Okay, it's just the data is different. Okay, so let's see, this is the solution. Okay, suppose we have this data set. Find the median. It says here that the following are test 1 scores from one of my elementary algebra classes. Notice that from one of my elementary algebra classes, so it's not all, right? Okay, so we know actually from the first sentence that's already a sample. My second sentence, just to emphasize, it is a sample. Okay, so let's say this is the sample of all my elementary algebra classes, a sample from my elementary algebra classes. Now, then part A, find the median. To find the median, we need to first find the position of the median. How many data here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 5, that's 53. So there are 53 data. 53 plus 1 over 2 give us the position. That's the 27th data number 27. So there are 10, 20, 1, 2, 3, 4, 5, 6, 7. That's our median. So the median is 58. Second, what's the mode of that data? What's the mode? I see 86 happens 3 times, but nothing else happens 3 times or more. So the mode is 86. The third, what is the first quartile? Now notice that data number 27 is the median, right? This is the median. So the lower half, only everything up to this 58. Okay, so there are 26 data. There are 26 data points in the lower half. 26 data point plus 1 over 2 give us the position. That's the 13.5 data. So what is data number 13.5? That's data number 13th and number 14th. Data number 13 is 38. Data number 14 is 39. So the first quartile will be 38 plus 39 over 2. That's 38.5. How about the third quartile? Same thing, 13 and the 14 from the top. From the top, you will see data number 13 from the top is 79. You can count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Right? So data number 13 and 14 are both 79. So the third quartile is 79 plus 79 over 2. Remember, every time the median or the quartile is between two numbers, you have to write it this way. Okay, you have to write it this way. So that's for the third quartile. If you see the number of points here, this is the number of points for that questions, right? First, it tells you the number of points for that question, but it also tells you how many minutes you should spend for that question. That also tells you how many minutes you should spend for that question. So if there are 2 points for that, you should spend at most 2 minutes for that, maybe less, very likely less, but should not be more than 2 minutes. If it takes you more than 2 minutes for that question, it means something not right with your understanding. You're working too hard, or you just don't get it. Okay, so the number of points for a question also implies the number of minutes you should spend to do that problem, or less. Okay, so it is possible, like number 6 here, you will see later on number 6, you see 7 points, which means you should spend at most 7 minutes when you do that problem. Okay, now number 5, what is the range? The range is the maximum, which is 104, minus the minimum, 8. So the highest score in that class is 104, the lowest score is 8. The range is 96. Now then number 6, create a frequency distribution with 5 classes from the data above. We need 5 classes. The range is 96. That's from number 5. So what is the class width? The class width will be 96 over number of classes. It gives me 19.2. But we always round up. It gives us 20. Okay, so the class width will be 20. X here, the frequency here. The minimum is 8. So that will be the lower class limit of the first class. Is it okay, everybody?
Yes.
Okay, now then, because here's the thing, like what we do here is actually scaffolding all the way to number 9. So if you have anything you don't understand now, you better ask now. Okay, now then once we get the lower class limit of the first class, we add the class width to get the next lower class limit, So I keep on adding the class width here. Add the class width, add the class width. You see? Okay, keep on adding the class width until you have 5 classes. So this will be 68, this will be 88. Now then, the upper class limit for each class, basically the next lower class limit minus 1. Okay. Now you will see this phenomena that for the upper class limit, you will also add the class width, add the class width, add the class width, add the class width. Always like that. Always like that. Okay, so I will add the class width 20, give me 87, add the class width 20, give me 107. Now I do the tally. 8 to 27, 8 to 27, to 47, to 67, to 87. Okay, so these are the cutoff. Let me make it a bit smaller so that you can see better. So 8 to 27. From 8 to 27, 1, 2, 3, 4, 5, 6. There are 6 of them. So the frequency here is 6. 28 to 47. 28 to 47. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11. From 48 to 67. So this is 10, 11, 12, 13, 14, 15, 16, 17. There are 17 of them. Then from 68 to 87, I saw there are 13. And then from 88 to 107, there are 6. Now then I add these 30, 41, 47, 53. And yes, I have 53 data there.
Can you scroll down a little, please, Professor?
Yeah.
Question. So it's okay for the maximum range to be more than the maximum of the data?
Yes, that's okay. Enlarge this back to 125%. So that's what I have here. Now, once we are done with this, then the next question is number 7. Copy the frequency distribution in number 6 below. So you will copy this frequency distribution. You will copy that below. And then extend with lower class limit, upper class limits, lower class boundaries, upper class boundaries, and relative frequencies. Okay, and I give 8 points for this. You can say that this question is actually a bonus question, and it's a big bonus question actually. Okay, I say it's bonus question as if like this is so easy that I should not even ask that anymore. But I still have students don't even know what is lower class limit, what is upper class limit, so on and so forth. You know, and of course, if they don't know those terminologies, then they will lose points here. Okay, but the first thing is copy that first. and anticipate that we will extend it. So let me make it big right away. So my axes are from 8 to 27, 28 to 47, 68 to 87. No, 40. 48 to 67, and then 68 to 87, 88 to 107. And the frequencies are 6, 11, 17, 13. 6, 11, 17, 13, 6, and then I still need to write the total is 53. Okay, that's the copying part. Now then, I can ask you to do this though, give you some time to do this. Lower class limit, upper class limit, lower class boundary, upper class boundary, and then relative frequency. Okay, let me give you 1, 2, 3, 4, 5 minutes to do this. Let me give you 5 minutes to do this one. Right now it's 5:50. We come back at 5:55. Okay, the lower class limit for the first class is 8. Lower class limit for the second class is 28, 48, 68, 88. Upper class limits for those classes are 27, 47, 67, 87, 107. Basically, the numbers I put here are from here. And the numbers I put here are from here. Okay, very easy, right? Okay, now I don't really see people making mistakes when they construct frequency distribution, except they usually make mistakes here. They think that the upper class limit for the last class has to be the maximum, which is not true, okay? The upper class limit of the last class still follow the pattern where you keep on adding class width, class width, class width, class width, like that. Okay, that's how it should be done. Now, how about the lower class boundary, upper class boundaries? I will get this first. 27, 28. The midpoint is 27.5. So this is 27.5. That's the fence, which is shared with the neighbor. Okay, and then the next boundaries, 47.5. 47.5 is being shared by the second house and the third house, and so on and so forth. And because the gap is half unit from the house, then this will be 7.5. This will be 107.5. How about the relative frequency? Then this will be 6 over 53. That's the frequency of that class divided by the total frequency. Then the next one is 11 over 53, 17 over 53, 13 over 53, 6 over 53. The total is 53 over 53, which is 1. Okay, now the blue ones, the one I write in blue is the one you should show me the word. Okay, now for extra, I said before that relative frequency usually be given in percentage. Okay, so what will that be if we write it in percentage? That will be 11.321%. So if you write it in percentage, still make it 3 decimal places from the decimal point. 11 over 53, 0.207547. In percentage, that will be 20.755%. 17 over 53, that will be 32.075%. 13 over 53, that's 24.528%. And 6 over 63 will be 11.321%. A total of 100%. Okay, so the one I write in yellow is something you don't need to show in your test, but in real life, that's what you're supposed to show instead. Okay, now sometimes they just want you to round it to 1 decimal place, sometimes 2 decimal places is reasonable. In my class, because I want it to 5 decimal places in decimal, right? 5 decimal places in decimal, therefore the percentage will be 3 decimal places. Okay, now that's for number 7. Any question? No question. Let's go on. Remember I said that we will put things together? Basically, whatever we learned before, right, since the very beginning. Mode, median, mean. Okay, constructing frequency distribution. The quartiles. Lower class limit, upper class limit, lower class boundary, upper class boundary, relative frequencies. Right? Okay, now in number 8, we will copy the frequency distribution from number 6 again. But this time we will extend it to find the mean, variance, and standard deviation. Okay, so I will copy this frequency distribution there. I will copy this and put it there. And they told us this is a sample. Right now, after I copy that, then I will extend it. To find the mean, variance, and standard deviation. Now, do you remember how to do this? We did it last week on Wednesday. This is group data interval. Now, how do we extend group data interval to find the mean and variance? What is the first one? Anybody remember? Xi, the midpoint for each class.
XI,
And then after that,
FXI,
and then after that,
XI square,
xi squared, and then
FXI square.
XI squared.
fxi squared. Okay, let me ask you to do this then. Okay, extend this table. The number will be quite ugly though, because the midpoint is, I think this one here will be 17.5. Yeah, it's like half 1 decimal. So when you square it, you will get 2 decimals. Okay, but okay, try to work it out. Let me give you 10 minutes. So from now, we come back at 6:13. Okay, you do it. So I will get the midpoint for each of these class. This is 17.5. This is 37.5, 57.5, 77.5, 97.5. And then multiply each of them by the corresponding frequency. I get 105 here. Let me go horizontally. 17.5 squared will be 306.25 multiplied by the frequency 1837.5. 37.5 times 11 is 412.5. 37.5 squared is 1406.25 multiplied by the frequency 11. That's 15,468.75. And please make sure that when you write them, you line them up according to the place value. Okay, so what I meant is like the decimal point should form as a line. Okay, the decimal point should form a line. This is for aesthetic purpose though, just make it look nice. And then 57.5 times 17 is 977.5. 57.5 squared is 3,306.25 multiplied by 17. That's 56,206.25. 77.5 times 13. That's 1007.5. 77.5 squared is 6,006.25 times 13 will give me 78,081.25, and then 97.5 times 6 give me 585. 97.5 squared, 95.06.25 multiplied by 6. That's 57,037.5. Then this is our first number. I need to find the second number, the sum of fx and the sum of fx squared. Right? Remember, we need to find the mean and the variance standard deviation. Okay, so what I will do next is to get the blue color. 105 plus 412.5 plus 977.5 plus 1007.5 plus 585. I get 3087.5. Now, because this is a sample, so my X bar sample mean will be 3087.5 over 53. Now they say, the question say around 3 decimal places. Right, so this is 58.2547. That's the sample mean. Now I hope you remember this far, okay, from the past, from our Wednesday class. Now I will add the last column, 1837.5 plus 154.68.75 plus 56,206.25 plus 78,081.25 plus 57,037.5. Now, before you press enter, make sure you check the number. It's quite easy for us to kind of like try to do it so fast and at the same time do everything like imagine if you punch one number wrong and the whole computation will be wrong. Here I get 208,631.25. So my sample variance will be the first number times the third number minus the second number squared over the denominator will be 53 times 1 less than that. So you have to memorize the formula, okay? At least the formula should be on your cheat sheet and you know how to do it, okay? You know how to do it. So from here, compute further. I get the sample variance to be 553.26560 such that the sample standard deviation will be the square root of that number. I get 23.5215, so 522. That's the sample standard deviation rounded to 3 decimal places. Notice that this number 8 will not be correct if your number 6 is wrong. Okay, the number you get will not be correct if your number 6 is wrong. And keep in mind that the variance and therefore standard deviation will always be non-negative. Yeah, we expect the variance always be positive number. The variance will only be 0 if all the data are exactly the same. No variation, right? Okay, but if we have different data, the data set consists of different data, then the variance will not be a negative number, not even a 0. It must be a positive number. Now, number 9. What is the interval within twice standard deviation of the mean? Some extra note here. Note. The interval within twice standard deviation of the mean, within twice standard deviation of the mean is called usual interval. Our textbook use different definition of usual interval and outliers. Okay, I use this definition. Now, this is the definition being used, especially if the sample size or population size is at least 30. This is the one we use. Okay, our textbook use different way, different definition, which I will not use. I will not use that because our sample size or population size in general is at least 30, right? So the proper way to define usual interval will be twice standard deviation away from the mean. In other words, if I go down here and show you the explanation, let's say this is the mean. Let's say this is the mean here, somewhere here, either x bar or mu. you add twice standard deviation from the mean to the top and subtract twice standard deviation from the mean. Not 25, that's 2s. Okay, now then the usual interval is defined to be this interval from here to here. That's what we call usual interval. Now, later on, any outcome that is outside of that interval is called outlier. Okay, any outcome that is outside of that usual interval then is called outlier. Okay, but the usual interval is the one within twice standard deviation from the mean. Now, what is the idea behind this? Like if we look back into this original data here, right? Okay, when we look back into that original data, how do we know if the 8 is the one underperforming or 104 the one overperforming? Or are just both of them are way too far away from the mean? They are just outliers. How do we decide that? Okay, how do we decide that? Now, statistic does not allow us to make decision after you know the data. Okay, so there's a rule of thumbs in statistics says that usual interval is if it is within twice standard deviation away from the mean, and anything outside of that will be considered outlier. Okay. You don't look at the data first and then say, oh, you know what, this 104 is the one overperforming. That this person must have taken this class before, and this 8 is just like this group of people here is the people that we feel sorry that they don't do well. They seems to be not doing well because of these people here, but they are actually studying really hard. No, we don't do that kind of assumptions. Okay, it is possible that you think they're studying hard, but it turns out that they're not studying hard enough compared to the rest of the class, right? So how do we decide if Thomas test is too hard or too easy? Okay, Thomas test is too easy if we have outlier at the bottom. Thomas test is too hard if we have outlier at the top. Okay, like basically the data is concentrated at the bottom, like that. Okay. But the thing is, again, we cannot make the decision after we know the outcome, though. Okay, we need to set the rules for our decision before we see the outcome. Okay, that's why since the beginning I said before that I do not give extra credit outside of what I said in my syllabus. Why? Because I do not want you to see that you start not doing well, then you start to want to do more work. No, you need to start working hard since the very beginning. Okay, assume this class will be hard. Okay, yeah, assume this class will be hard. So coming back here, before we decide which data is outlier, we set up the usual interval first. Okay, so the lower fence or lower fence is the sample mean minus twice standard deviation. Or in case of population, there will be mu minus twice sigma. This will be 58.255 minus 2 times 23.522. I get 11.211. The upper fence of that interval will be the sample mean plus twice standard deviation and I use my calculator to compute it. I get 105.299. So the usual interval will be, the interval from 11.211 to 105.299. That's the usual interval. Okay, then what will the outliers be? Now, compare this interval 11.2 to 105 point approximately 3 with your original data 11.2 something to 105 point something. That's the usual interval right now. Then which data in this raw data not in this interval? And you will see 8 is the one not in the interval. Okay. Because the usual interval is from 11.2 something to 105.2 something point 3. And anything outside of that, in this case is 8, is not in that usual interval. Therefore, 8 is the outlier. Okay. That's how we know if if like you want to see if this class is overperforming, underperforming, or who is the person, is this 8 is the one underperforming, or 104 or 102 the one overperforming, right? It turns out that no, that's 104 compared to the rest of the class still reasonably between in the usual interval. It's the 8 is the one that is underperforming terribly. Okay. So you see that, do I use my scales to decide who is the one overperforming, underperforming? No, I use the data itself to judge each other. So these 8 here compared to the rest of the class are very different. Okay, I did not use my standard, you know what, you got 8 and the passing is supposed to be 68, so on and so forth. Yes, we can say the whole class is actually not doing that well because the passing is 68 while the average is 52 something. Is it right? Let me delete this first. So the outlier is 8. Okay. The one not in the usual, not inside the usual interval. The mean we found to be 58.255, which is not passing. The average is not passing. So yes, on average, this class is not doing well, but if you take a look on the numbers here, you see that we have how many people actually passing the test. 19 of them passing the test. Okay, now some of you may say, well, but Thomas, it's supposed to be majority passing the class and your situation is that majority not passing the class. Well, you can say that majority of students in that class not passing test 1, but should we talk about what number they came into my class with, like how they did in their pre-algebra class, for example, right? Okay, maybe they came from easy teachers such that they get passed by mercy and they think they are so good that they don't need to study for the test 1 in my class, right? But in the end, it's like I will use your data against your classmates to do the comparison. And whoever, if they try to, this person here try to complain, then I will show the rest of the data, right? I don't think if you get 104, then you will complain, right? Okay. By the way, this is the technique being used when I was in my undergraduate study, the teacher didn't tell us, our teacher didn't tell us that what is your score supposed to be to get an A. They just say this, okay? This is the how they decide who get an A. The one who get an A, if your average is greater than, the mean, the class mean, plus 1.5 standard deviation. You got a B if your average is between the mean plus 0.5 standard deviation, the mean plus 1.5 standard deviation. So the class average may be very, very low, but you still get an A. It is possible that the class average is very, very high, but you still end up with a C. That's what we call curve. That's the actual meaning of curve the grade. Okay, when we say we curve the grade, then it will be independent of how the test is. The test really hard? Even if the test really hard, but some students still do perform better than the rest of the class. Okay, so here's the thing. Imagine if the whole class get 94. Let's say there are 11 students in that class. 10 of them get average of 94 and 1% get 95. Okay, so 10 of them get 94 and 1 of them get 95. Then the total will be 940 plus 95. That's 1065. So the average, let me call X bar, the average will be 1065 over 11. So the average is, oops, am I adding something wrong? No, this should be 35. 1035 divided by 11. That's 94 something, 94.09. So then all of a sudden, even though everybody here, the 10 students here get 94, really good grade, right? But comparatively, they are actually below average. They end up with a C. That's what happened in my undergrad study. So it's like when people ask me, Thomas, do you curve? And I ask them, do you really want me to curve? Because compared to the rest of the class, you are actually very underperforming. Your C may end up with an F if I curve it, because what it means to curve is basically doing it this way. Okay, now we can compute the standard deviation. You will see that this 95 is very far different from, very far ahead of the mean, while this 94 is slightly below the average. So what will happen is, I think these 10 people will get C's and this person will get an A. If I don't curve this, everybody will get an A. You want me to curve it, then what happened is 1% get an A and the rest of the class gets C's. With this method of computing the grades of the class, then what happened is for every one person, pretty much like this, for every one person getting an A in that class, one person needs to fail. Almost to that to that kind of notion, like for every one person, because the grades usually symmetric, right? When we kind of like see most people is around the mean, there will be 1 or 2 people doing very, 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 very well. But because it's bell-shaped, then there must be 1 or 2 people doing very, 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 very bad. So you see that the extreme that we have here will be compensated by the extreme we have there. So for every 1% get an A, somebody needs to get an F. Kind of like that. Okay. So what happened, Thomas, if everybody is not doing well? Well, with this curving here, the way it is being curved, then no, it will not have that. You can have, imagine if I once took a test and I get average of 30 something, I still get an A. Why? Because the rest of the class get 20 something. Okay. So we may say, well, your test is too hard, and then my professor will say, don't worry, I don't grade it that way. I don't grade it based on the cutoff like I do in class, right? Like 68 for a C. No, my professors, none of them doing that. They say, I will curve it anyway later on, so you can get 30 and still get an A. You can get 94 like what you saw earlier and still get a C. Okay, it's really about how you do compare to the rest of the class. Okay, now this is where I will stop. Okay, we did number 1 up to number 9 already. So what I suggest you to do is, at least this weekend. Okay.
Can I see number 9, please, Professor?
Sure. Number 9 is here.
So that's how we would answer. The outlier would be 8 because it's under, and then we would say upper and lower.
Basically everything outside of the usual interval will be the outlier. Yeah, so see this lower fence is, this lower fence is twice standard deviation below the mean. Upper fence is twice standard deviation above the mean. And now this interval is the usual interval, and any data in the raw data that is outside of this interval is called outlier.
Thank you.
Okay. Now, since all my tests number 1 to number 9 have the same questions, different data, of course, I strongly suggest you that this weekend, okay, let's say on Friday or Saturday, beside working on this the quiz, I think we have quiz 1 and 2 that is due this Saturday. Let me see. I believe we have quiz 1. Oh, assignment. Yeah, we have quiz 1. Oh, we have quiz 1 due this already last. So I will post quiz 2, 2 and 3 maybe over this weekend, or maybe no quiz at all. I will see, but at least that between today and next week, you should print out all test 1. Maybe not all. Print. Let me write it above. Print some all test 1, and do number 1 to number 9. Okay, maybe 2 or 3 of them. Number 1 to number 9 is procedural. Okay, it's they are procedural, so you should be able to do it already. At least do it this weekend. Okay, this is where I will stop and see you on Wednesday. On Wednesday, we will talk about lessons, exercise from lesson 5 in announcement 3. Okay, see you then.